So for today, I didn't have too many items. The biggest things is there's a pull request on for SimPEG dev to master, which is big. It's exciting. So I'll just share my screen. And so if we go to make sure that's being captured. Cool. Okay, so this guy is big, but we've already done pull request reviews like on all of the code, so we don't actually have to go through and do a whole nother review. The biggest thing, the biggest thing I'm hoping for is just like if you guys have encountered anything weird or there's like stuff that you think should be changed, especially with the objective functions, let's like make that known. But otherwise, like, I think we can get this in this week.
It's all running.
Yeah, it's working away, and we might as well sort of get people over to this.
That's good.
So that's cool. The other quick update from me on this front is on discretize. The SILMesh stuff I would like to bring in. And so we should have the 3D SILMesh then onto dev, which is exciting. One of the things that this will change is that in the, there's one sort of non-backwards compatible change that I made in the way that the cell grad is defined. So originally we had sort of these cell grad stencils being methods, but really they're properties. So I turned it into a property, and then the only thing that means we need to do is go in and change the reg mesh in the regularization. So I can go do that, but then what that means is we actually have to sort of stay in sync between SimPEG and discretize. So, like, I mean, we can post a notice and just tell everybody, you know, like, make sure you update your SimPEG to include this latest change. But the other thing I was kind of thinking is that maybe on import of SimPEG, we just do a quick check of the version of discretize and tell you to upgrade if you're out of sync.
Yeah, we should do it for all of them too, because what are we depending to? Depending on properties, discretize, and then. Yeah. I think if we got one. And it already happened a few times that people forget to update them on.
Yeah, that's fair. So properties, discretize.
What else?
I mean, there are.
Like about the C.
Hey, what's it?
No.
I don't think we need to check the version, hopefully.
Well, sometimes happens, like with the update stuff, like it's compatible.
Hey, speaking of, so VTK, is it only on 2.7?
I don't know.
The VTK script that we have is not working with Python 3.
I've never tried, like Python 3.4, I've never tried.
If you ping Gutney, I bet he would know that.
He's on 3? Do you know if the Gutney is on 3?
I'm not too sure.
He said he's going to go field trip. Not sure he's already gone.
Yeah, he's gone, but he is in internet touch.
Okay.
At least periodically.
Okay, I'll ask him.
Yeah.
It's a bit frustrating.
Yeah, if not, the other thing you can do is set up like a conda environment. And so you can just do like conda activate, you know, pi27.
I see.
And then you can do your stuff in Python 2.7.
Yeah. I've never done that, but that's.
It's not too bad. There's some decent docs on it.
Okay.
Yeah, I just did that yesterday to simulate 3.6, and that works well.
Because you were working on 2.7, but you wanted to use 3.6. Gotcha. Are you a PC? No, you're on this.
I think I might be the only PC here.
No, I'm PC too.
The other thing I just wanted to check, I'm actually just going to look at the SimPEG email and see what else I have on that list. Well, yeah, I'll maybe turn it over to Thibaut. Thibaut's made some changes in EM examples And then he's also got 2 pull requests on, one in SimPEG and one in Discretize. So if you could just give everybody an overview. And then I called out both Seogi and Dom on one of them, just because it changes the utils, the topo util. Which one is that called again?
Surface topo.
Yes.
Something like
Yeah, so just like if you guys could check that it works as you expect,
Yeah.
that would be good. But I'll let Thibaut give an update on that.
Okay, just let me know. What is the button again to share the screen?
If you go over to the mouse over here.
Okay. Sure. Perfect. You see. Screen sharing. Can you see it now? No.
Yeah, that's it.
Oh yeah.
Yes.
Okay. So what I was working on putting like a new DC apps, but with like much more complex geological setting for like both for visualization and communication for my PhD project. So that's something. But actually, ipywidget made a lot of updates. So all our apps were not working anymore. We had like issue of like figures duplicating and all stuff like that. So I went back to what Lindsay did with the base.py file, which basically create a new class myapps that give us a bit more like control on the widget. So just to like, so I had to go through that to make things working and to unify a bit everything, because we have some apps that like are fairly quick, so we can run them very interactively, while some are like the 2.5D DC code are fairly slow. So we just want to update on a click saying like run this, and interact runs that, but with a different things. So now instead of using like what Lindsay did before was like, instead of using interact, we use this widgetify function here. And now to have like a manual or interactive function, it's just this single argument here, manual, that is true or false, and everything else is take care into that. And so one issue we had also is that interact and interactive act differently. So interactive is really like, it's kind of like the my app class. On top, it's like a manager for your widgets, but it's not running actually the thing. So you have to say it to run after that. That's the app.update here. And for the interact manual, that also says that when you launch it for the first time to run it, otherwise it's gonna wait for you to click on the thing. So the only thing that appears on screen is only the widget and not the first simulation. What we were doing before was this app done on displayed, but that was creating a new figures. So that's what was creating the issue of like having 2 figures, etc. And so,
what is the line 30 does?
which one? Line?
Like at line 30, yeah. There.
Oh, it's because of the difference between interactive and interact manual. Like I went through the ipywidget code, and if you want to think of it, interactive is kind of like the master class of it, and then the interact and interact manual function are created based on that interactive. Like you can write yourself like create a new function in. Like, for example, interact will be interactive.option and nothing, and interact manual will be interactive.option manual equal to, etc. But that it's just different class, because when you do an app interact like this, it's basically adding, like when you have your function, it's adding the a widget thing, while interactive is kind of its own app class too. So that's why by doing app.equal app.widget, now the 2 app here in the if statement are the same class.
Thibaut, just maybe a clarification. So correct me if I'm wrong here, but the Interact manual would have does that separate out sort of like the action that it's taking and the widgets? Or, because I know like the widgets are sort of their own class.
Yes.
And so in this case, oh, it's just what interactive gives you back as well, I guess.
Yes, because interactive give you back the widget
widgets.
box,
Yeah.
while interact manual give you back the function.
Okay.
So, but the function has an object widget, so you can grab this widget thing back.
Cool.
And the app.update now here, like it took me a long time to find that one-liner, but it's updating the app without creating a new figure, so it's really like just acting on the output.
Okay, the current axis.
Yeah. And so and also like one thing that can happen maybe later, but like for the run for manual, the run button for the manual is considered a widget too, but it's not an argument. So, and the output is also a widget generally. So that's why also here in the my app function, I create this like lambda function instance check. And it's basically all, like right now it's fairly ugly, but it's like all the interactive button we use. So checking if it's like, basically if it's an argument, if it's a float slider, an int slider, float text, or things like that. And then that it's put like in our property quags. Because otherwise before in the quag, we also had the manual button and the output, but then we were using this like this property, for example, here.
Thibaut, just to clarify, so the
Yeah.
thing that you're trying, so instance check. So you're trying to exclude things that are not widgets?
That are not widgets that give us argument to our function.
Okay. So yeah, my only comment here is that we might be able to do something a little more transparent. So, because like it looks like what you're working to do is exclude. So the only thing you wanted to make sure you're doing is excluding the run. Run toggle.
The run toggle and the output also, because the figures inside the app, it's not a its class is not a matplotlib figures. It's a widget.output.
Okay.
So it was recognized it. If you just check if it's a widget, even the output gonna be grabbing to the arguments.
Okay, cool. Let's connect on this afterwards. We don't have to spend time on it now, but just to try and make it a little more like these few lines, just a little more transparent of what's going on. But that's fine.
Yeah, right now I just like kind of like put every interactive thing we used.
Cool.
One thing also that was kind of like unclear is like this fixed argument sometimes because we don't see it. Like it's like it's when we don't want an interactive.
Yeah.
So we don't see it, but we still need to pass it to the function to run. So that's kind of the change I made, and so that's been deployed yesterday.
Should be, yeah.
Okay. So
can you run it like and see, show us like how it looks like now? Because like it was a bit of like there were quite a bit of problems. So
yeah,
I just want to show.
I don't think I have Azure.
No, like not Asura, but like on your end.
Sure. It's basically on the user end. There is no change at all.
Exactly, like that's what I exactly.
That's what you want to see.
I just wanted to see that that's actually like working.
I might actually load the new DC app I put together. So.
Sure.
So while it's loading, I might show you just like the pull request. I have these days on So I have one on discretize. So now it's backward compatible usually. So now like before we had the read UBC function that was reading 3D mesh only. So now when you do a read UBC, you can the file you import can be either 2D or 3D mesh, and the function is smart enough to recognize it automatically and grab and import it as a 2D or 3D mesh. And so it should be like, and it's the same name and the same argument, so that should be backward compatible too. And the other one I had, so this one, if you can check it, Dom or Seogi, because I think you were using it, like the surface topo.
So that was in that pull request? Like a surface to topo was in that pull request?
So read UBC, it's a discretized pull request, and it's on its own, while the surface to index topo is in SimPEG, yeah. Why that's so long?
Do you want me to pull it up on here?
I don't know. Oh, that was here anyway. Yeah, so, and this one, also I added a few options. So now it works both on 3D and 2D mesh. I had some issue with that also. And now you can also choose your interpolation method for your grid, either nearest, linear, or cubic interpolation. Like for topography, it seems like most of people like to do a cubic interpolation, but it's not now. It's just up to you as an
What are you using? Like it's for interpolation there?
Oh, it's a SciPy interpolation tool.
Yeah, I'm not sure. So what is it? What are you using for cubic then?
Oh, it's the SciPy interpolation tool. It's basically it's the same argument in the SciPy
right.
function.
You only need a 2D, right? That's true. Okay.
Can you show us when you go down?
Yeah. So it's
using grid data.
I use grid data, yeah. And so if we go, so here method is what you pass as like the nearest, or like here I put nearest because that was the one we had by default before. And you also have the option to put what you want, if you want to extrapolate what you want as a field value. So by default in SciPy it's a none, but we like it's part of the argument for the function too now. So if you want to change it.
Can you go down a bit?
All of them have extrapolation. I thought only the spline had the extrapolation. Does nearest neighbor has extrapolation? Does extrapolation?
The field value, I think you can like it's either like one function can do extrapolation and the others you can just put a constant. I think that's the only option you have.
Oh, okay.
Well, it does work. You find the nearest cell, so
you will shoot out as far as you can.
Yeah.
But I thought, okay, no, that's it.
What you wanted to see, Seogi?
just can you go quickly and then I just wanted to see how. Yeah, have you tested like what was that? The grid, like when grid location is N and also the CC. Like, have you tested both? Like,
yeah, I've used and I actually if I go.
Because like, what can you tell us? What was your problem before?
Oh, before I think that was the nodal formulation was working, and in the cell center it was just a small mistake, like of in the indices when grabbing one vector. Like it was supposed to grab a matrix, and it was only grabbing a vector. So when you were doing a comparison, like you were only comparing along the x-axis and not the z or something like this. So what, like for the CC, it was like not that hard to correct, just like the time to find it, and then I just took the occasion to bring some improvement for like having 2D and 3D working with the same function, and like this interpolation option to put in.
Yeah.
And I also add a test in the testutils.py file. So now it's how it works is that I have a file which is basically the topography of Vancouver, and I create a mesh, and I just check if my number of active cells are consistent. So you have a small difference, obviously, between cell center and nodes, because in one formulation you just want the cell center to be below the surface, while in the other formulation you want the whole cell to be below the surface. So obviously we have a bit less cell for the nodal formulation.
So what is the default now? Say I have a point, it's like you have a big mesh like that.
Yeah.
And I have a point like somewhere just inside of here. And then like, if I don't, like, what is the default of the field value?
The default will be the nearest point.
Okay.
And cell center or nodal?
Good question. By default, it's cell center. And it was a default before, and that's why that was confusing, because the default was not working.
Thibaut, would you mind actually expanding there is one example that uses this. Would you mind like either expanding that example or creating a new one that just shows like the difference between each of these, as well as like some of the different methods, because that's sort of new functionality that we didn't have before?
Yeah.
That would be awesome.
Yeah, I can use the same example I used for the test.
Yeah,
like
that would be great.
I have the notebook already ready for that.
That would be awesome.
And so we're thinking about doing this checking the EM apps. Oh, it's slow things down a lot. But basically, within the EM apps, it should not change anything. And like the way I wrote the base.py functions, like it took care also of the different way we do the widget, because like the DC apps doesn't work the same way as the dipole apps.
That's true.
Like that, the dipole app where actually like was super important to have the app.updates, because you like once you like when you run your widget, it creates new properties, and then you're using these properties later in your apps. So if you didn't run the app first, like the next one will fail.
That's true. That's true.
Okay, it didn't actually deploy yet, but I'll deploy today, and then I'll ping you guys, because it'd be great if you wouldn't mind just double checking on Asura that the notebooks you wrote are still working.
Yeah.
Because the one thing, where did you have to add plt.shows?
Oh, that's true too. Like now, if you want your figures to not duplicate, that was also an issue. Like in your plotting function, it should finish with plt.shows. Before, I think it was causing issue, but now it's not putting in that causing issues.
So can you run the actually empty one just to check?
Oh yeah, I didn't check that one.
Well, I think what I'm planning to do, I'm going to go through all the apps and see if that's working.
Okay.
Well, I'm going to use it in the course, and I don't want to see the stacking of figures.
Yeah, I'll get it deployed like just after this meeting.
Yeah, because like there are a few issues that plt.show and also the app itself. So I wonder actually that is fixed now.
Yeah, like the plt.show, I fixed it in the DC apps, but
not
not the other. I didn't went through all the apps. So it's very slow with Google now, but yeah.
Yeah, well, I think we can do it now.
Yeah.
One quick thing that came up, and I think Mike encountered this, I encountered it, and I know a few other people with Macs. When they updated software, it exposed a bug in Python. So if you typed Jupyter Notebook, it wouldn't know where to launch. So it wouldn't automatically pop up in Chrome. And so what you can do to overcome that is, actually, I'll just pull up from Software Underground. In Python. So I was chatting with, sorry, Thibaut, switch off your screen. Chatting with a couple people on Software Underground, and who was it that? Yeah, so the fix, and all I've done is added this to my Z shell config, basically, is just doing Jupyter Notebook -- browser equals whatever, Chrome. And then in that case, now, like by telling it which browser to look at, sorry, I'll post that on Slack.
And then which update was that?
If you do a software update on your machine, on your Mac.
Oh.
Yeah, so. I will post that guy on Slack.
Always scared to do that. Don't want to do that.
Yeah, so that's a pretty quick fix.
And that's why you still have to put that in your.
Yeah, so I have a shortcut that I just do like JPMB, and then I just say JPMB is this. So it's Jupyter -- browser. Cool.
I think the thing I found was something slightly different, and it doesn't work all the time.
Okay.
Like I already have to have, Chrome open and launched
Oh, okay.
for it to
Yeah.
be able to find it, and
This seemed to work for me and
Nice.
the Software Underground crew. So cool. Okay, well, so on my action item list is I'll get EM examples deployed so you guys can check on the things. And then I'll maybe give like another 2 days on the EM or the pull request for SimPEG. And if there's anything like urgent that you guys think needs to be dealt with, that'd be great. Otherwise, we'll just kick it out to the world and wait for feedback.
Yeah.
So
That's a good way to do it.
yeah.
I appreciate your work.
Yeah.
Do it.
Fair enough. Will do. Yeah, anything else you guys want to go over?
Yeah, I want to show. Okay, so I've been working on Lindsay's.
Do you guys joining a Hangout? You can use this, but we'll just need you to screen share.
I'm just so offline.
Yeah, so what Seogi is going to show while he's joining, we got reviews back for the EM paper, and overall pretty good. They asked also for a field example, so we're looking at adding bootcamp. Cool. So I will switch over to Seogi whenever you share your screen there.
Okay, so I was trying to use Bukunom data, and probably some people have some experiences. I got some research. I wasn't sure if that's really reasonable research. So I was trying to kind of show you guys. So this is Bukunom data. I loaded up with SkyTem and Resolve. So Resolve has 10 frequency, like 5 frequency, but they have one VCA, so it's basically like 6 frequency. So you have 12 components of data. And I didn't know, but the Dequan said like putting a highest frequency is kind of dangerous because I was actually testing the accuracy. The highest frequency doesn't match because probably like the displacement current, I guess. So I've heard even from Greg Hodgie, and he said like they had to put the epsilon to fit the highest frequency. When you're in a conductive environment, that was important. So
That's something that we could also think about doing down the road is adding that in.
which shouldn't be hard. And the SkyTem waveform, just using the low mode. So that's the data profile. pick one point and run the inversion. So this is the cell mesh. Okay, so I got. It took a while to play with it, and then what I have found, it's like I need for initial model, it's better to put a resistive model. So I started with 10 to the minus 3 because I believe like their near surface is pretty resistive, not very conductive. That was my feeling. Like I think from the data standpoint, I don't know about the geology at all almost, but from data point, like no way like to fit the highest frequency, you need to really like a resistive top surface.
Okay.
Otherwise, you cannot fit the data. So data fit is better. And then there were a few issues because I think it's very sensitive to actually fit the data. You need to really find cells on the top.
Okay.
So you need a few meter cell, like 1.5 meter cells to kind of get that point.
Okay.
Yeah. So that was interesting. Like, oh, wow, that's pretty high resolution. So that's the resistivity model. So it's about 1,000 at top, and then that converges very fast. So but if you start from 10 to the minus 1, it takes longer time to get there.
Okay.
And then, so anyway, didn't quite. I thought I started from 10 ohm was fine, but just didn't quite work to me.
That's interesting. So it's easier to put in a conductor than to put in a resistor. At least
No. I'm just, like if you think about you have a huge response on the near surface.
Yeah.
But your near surface response is 10 to minus your resistivity is 10 to minus 1,000.
Yeah.
But if you're starting from 10, then you're gonna get a really big misfit to go there.
Yeah.
Well, sure, it's gonna find it.
It's gonna take forever.
Not forever, but it'll find it, but because then your output will be a little bit different. So I'm not sure what is better, but I think probably starting from closer model might be better.
Yeah.
That's something also I've found in DC as well, because putting something close to your near surface is better. Then they start to find something deeper. Otherwise, you always update on the near surface.
This is where all your sensitivity is.
Yeah. As long as you're not putting other things it's going to update there first.
Yeah.
And then SkyTime, I think their sensitivity is quite different. Their high moment and the resolve data, their sensitivity is quite different. So I think what I did here, I just started from the resolve model, and then I used the resolve model as an initial model. Reference model is 10 to the minus 1. So that's what I did. Because I think they don't have that much sensitivity on the top part. So if you do that, you can get relatively similar model. Otherwise, you're going to get a little bit different model. So you could choose either doing this or just do a same setup and run the inversion. You could do that as well. And so that's the 1 point. So Doug wasn't happy about that. So he suggested, okay, what's the impact that we can make? So I actually inverted all the book-pronoun data, not all of it. So I heavily downsampled. But still, it's about 1,000 point. And it sort of captures, that's the topography. So you have a mountain here, not sure if that's a mountain, but something high. And you can see those this river path nicely in a topography map. I think that's an elevation, I guess, ground elevation. So I inverted, and that's the surface below 21 meter, and then 41 meter, and the 7 meters. So I think at 40 meter below, most of them are very conductive, which I wasn't sure that's right.
Yeah, it sounds very deep, man.
Okay.
If you had 10 ohm meters, those systems shouldn't see that far. I don't think so. But.
Yeah.
I wouldn't be surprised if that's just the smoothness basically hanging on at that point. Because the plots that Deepan showed, I think he plotted it like 8-meter depth.
That's one of the numbers that I had in mind, yeah.
Yeah, so he plotted really shallow.
Oh, I like the inversion. So that's something that I wasn't sure, because I think what I've got from that inversion result, it wasn't that like shallow.
Can you plot at
Oh, 8 meters?
yeah, or like roughly 8 meters?
That's very resistant. Whoa.
Yeah, but if you pull up, okay.
So what are the colors? Resistive as well? Is blue?
Oh, sorry. Like blue is resistive and yellow is conductive.
Okay.
So blue is about like 1,000 millimeter.
Near surface at 1,000? Is that real?
Yeah. Yeah. So I'm not sure. I'm like there's totally a possibility that I'm doing something really wrong. But I don't know because I checked a couple times and.
You have the case study.
Mm-hmm.
Nice.
Yeah, so I was trying to get similar images that I like, but the depth was much shallower compared. So that was 8 meter.
Mm-hmm. And his color bar
It's -2 to 1.
But then most of the not river part is around 1, right?
Yeah. Well, maybe not quite 1, maybe more like a 0 actually.
That's log, yeah.
Yeah.
So 1.
Oh, sorry. Yeah.
So I think if you look at my 21 meter depth, that's actually pretty similar. But I'm not sure why I'm getting. And well, I think he's doing quite a bit of sophisticated things, like he's doing this like inverting, go back and forth and stuff. Like his research might be better.
Yeah. But the 21 actually is like we do see
similar.
we do see like this structure in here. This resistive guy.
Mm-hmm. Mm-hmm. But yeah, that's something that I wasn't sure. So, like, if the top part is not very conductive, then, well, I don't know. Like, I'm pretty sure their lowest frequency is pretty low. It's 400 hertz. So if you actually compute the skin depth, that's pretty dead. So yeah, I don't want to argue with like, oh, can you see that or not? I wasn't really sure what's really.
What sort of color bar range do you have?
It's -3, like 1,000 to like a 10 siemens per meter. Well, sorry, 0.001 to 10 siemens per meter. So if I can change that as well.
Oh, but that's.
Well, that's about the same.
Yeah.
Well, I think I can kind of clip it a little bit more.
Yeah, sure.
He clipped the bank on his figures.
Yeah.
Oh.
Cool.
So that's probably a little bit better. Yeah. Can spend more time. Well, I got all the set up, so running it like takes a few hours.
Yeah.
So you could run it. Well, if you parallelize it, then probably faster.
Fair enough. Actually, that probably would be too bad too.
Yeah. Okay. Now I kind of understand why he put why he didn't include those parts.
These guys?
Yeah. Because like you got the high topography, and then those locations, like you're gonna get lots of people effects. Yeah. If you actually invert it, like if you look at my data, my result, it's quite a big resistor.
Yeah.
So yeah, now I kind of got it. Oh, okay.
Makes sense.
Yeah.
Cool. Yeah, I mean, I think that 21 meters is pretty close. Interesting that it is so much more resistive than T1s, but fine. And it'd be worth looking at the other papers on this and seeing where they're plotting depth slices. Because I think deep ones were different.
Yeah.
So yeah.
Okay, so this is like now, yeah, we just need to decide and then, like, like we don't want to put something different research. Like we probably want to put similar. You've got similar research. Okay, so that's something what we need to do. So.
Yeah, I agree. Cool. Well, maybe we can try and connect with Doug on that as well today, even, and go from there.
Okay.
You can ambush him right now.
Yeah, I know.
Cool. Anything else you guys want to touch on? Go over? Nothing much. Craig, is there anything you wanted to bring up?
There was just one issue I was going to check with Dougie about. I think one of those updates broke one of the regularization.
Oh, sorry, Craig. I haven't had a chance to.
That's okay. It's not urgent. I haven't been waiting for anything. So.
Yeah. Well, this week I'm kind of busy with Doug's course.
Oh no, that's fine. Yeah. There's no hurry.
Well, like all the regularization stuff's changed, right?
Yeah.
So I was using my multi-regularization at one point for SP code.
Yeah.
I removed it actually.
Yeah.
And then for all the IP code, but not for SP code. So it shouldn't be hard, but just need to do it.
Yeah, it's not urgent at all.
I'll try to do it like potentially this week, and then I'll let you know when I'm sort of done it.
Okay.
Well, it's like if you want to, even if you want to make an issue on it, and then like a couple of us can also try and help you jump in.
Right, that SP code lives in somewhere different, so probably like better to put things into SimPEG as well. And, so.
This is just kind of something I'm working on in the background when I have some spare moments between other stuff, so it's totally low priority, but just a reminder.
Fair enough. Keep on the radar.
Yeah, well, I'll update. But I think, Craig, if you want, I think you can use different options on there, like not inverting for the vectors, but inverting for like charges per scalar. Then I think that still may work, so you can actually play with it.
Yeah. Okay. Yep.
But anyway, I'll update that.
Thanks.
All right, thanks, guys. We will wrap it up and
Thanks.
see you next week. Have a good day, Craig.
See you later. You too.